Any questions on 6.1? We'll get to 6.2. That one's obviously trickier. Any questions that you can think of for 6.1 off the top of your head? I think that works. Yeah. If you guys want to turn to 6.1, so what I would do for the test for 6.1, it's a lot of history. No, not yet. I'm just kind of giving you a heads up for kind of what that would look like. Whenever you're reading 6.1, I would go through and highlight all of the people, right? There's Dalton, Mendeleev, Moseley, and kind of how they contributed, maybe write in pencil or just kind of highlight as well, how they contributed to the periodic table, just so that that's a quick, easy find for you, okay? Okay, who can tell me the name of the person who first got started in developing the periodic table in the 1800s, early 1800s? Please remember? It's actually a unit of measurement named after him. The atomic mass unit of measurement.
John Dalton?
Dalton. Dalton. Remember, you'll see the atomic mass, like let's say, you might see it as DA for Dalton, or you might see it as U for his like standardized unit, but that's a unit of measurement for the atomic mass unit, okay? So in 1803, what was that? 2 years ago. It's a long time ago, so long. But I think it's pretty cool that he found 5 or 6 elements. 1, 2, 3, 4, 5. 5 elements, okay? So remember too, it's not like he just found these elements. He decided that the compounds that he was seeing in life was not an element itself, okay? So he had to know that an element could not be broken apart into smaller pieces, right? Water, you can break it apart into hydrogen and oxygen. These are fundamental at their most smallest unit, right? So gold, whenever you break it apart, it's still gold, even whenever you get to the smallest part, okay? So he found hydrogen, oxygen. Do you guys remember what azote? He found azote. What's azote? He later said what it was. They changed the name later. He found carbon and sulfur. It's actually nitrogen. It's nitrogen. I know. But so he found the most standard ones, which are great, right? It makes sense that those are the ones that he found. Sulfur, carbon, nitrogen, hydrogen, oxygen. But azote is the one that he called it azote and then later changed it to nitrogen. So over the years, they started finding more and more elements to fill the periodic table. Some of them, it was transitional, so they brought in some elements. You'll look at some of the periodic tables, and you're like, what is that? And later they had to take it out because they realized it was a compound, right? It was multiple elements put together. It wasn't just an element. So who ended up being the father of the modern periodic table? So over time.
Mendeleev?
Yep. Mendeleev became the father of the modern periodic table. I'm just going to put PT, periodic table. And then how did he categorize the elements that he had? Definitely not what we have today, but the elements that he did have, which I think he was having kind of like 40 at the time that he did this, how did he categorize them by? Remember? He was categorizing them by atomic mass. Right? So he was categorizing them by atomic mass. And if you think about it, the atomic mass primarily comes from the number of protons and the number of neutrons in the nucleus, right? Because the electrons don't weigh a whole heck of a lot, but the protons and the neutrons do, okay? And the chemical and physical properties are very much determined by the atomic mass, right? Something that is heavier is going to take longer to boil, right? Okay. So he's the father of the modern periodic table. He arranged things by their atomic mass. And this was really interesting too. Let's see here. Let me see. I'm going to put this together. So he doesn't have, like, he didn't build like what we know right now, okay? He started to. But one of the things that he started to do, which I thought was really cool, was, I'm gonna do this, very blotched up version of it. But so let's say he knew this one, he knew oxygen over here somewhere, he knew nitrogen over here somewhere, and a few others, right? And he just had a bunch of them filled in. But what he noticed was like, oh, there's all of these other ones that we don't know. But I can guess their properties based on where they are. Okay, if that makes sense. So he said, I've got all of these, right? It's almost like putting a puzzle together and you're missing like 15 pieces, okay? You can look at the puzzle and be like, okay, that one's likely going to have a curved edge. It's gonna have a little bit of red in the tip, and it's gonna have this over here in the corner, okay? So he was able to look at the periodic table and what he had, and he was able to say, oh, okay, so we've got some missing elements here, a lot of them. But I know that there's this element that's gonna have this atomic mass, it's gonna have this number of protons, it's gonna boil at probably this point because he knew what was on the left of it and what was on the right of it. So he was able to come up with physical characteristics, chemical characteristics, the atomic mass, the atomic number of a bunch of these unknown elements, and just have it out there for scientists to then think like, gosh, we need to discover these, okay? So he knew the characteristics of a lot of them before they were actually discovered. And so then people went and then they later discovered them, which I thought was really interesting, even though the history of stuff isn't my favorite. But so, let's see here. All right, this guy. So he was the guy who he developed the technique for basically counting the protons, and he started arranging them in increasing atomic number, okay? All right, so when he started arranging them based on that atomic number, okay? So he knew the number of protons and of all of these elements, he started putting them together, and just by circumstance, the atomic mass, like how Mendeleev had it set up with atomic mass, started correlating with the atomic number, okay? So, because if you look at, like if you look at any of your periodic tables, right, the more protons you get, the larger the mass is. Because like we said, the number of protons, the mass is large, right, especially compared to the electrons. Okay, so let's see here. All right, so mostly also started developing the element box itself too, okay? So the example that they give you in the book is calcium. We can look at that, but I'll probably do another one. Let's do... Does any of you guys memorize the periodic table element song?
I'm working on it. I'm working on it.
Why? It's like, nope, it's
I'm
not high on my
working on it.
list.
Because you told me that if I memorized it by the end of the year, you'd give me extra points.
Yes.
So I'm working on it.
Yes. Okay. So, who was it in my class before? Genevieve?
Are they also?
No, not Genevieve. Gosh, what's her name? Gianna. She just knows like the first half of it because her middle school sister was like playing it over and over again because she needed to have it memorized, and so she knows it because of that, like
That's
the first
so
half,
cool.
because it's so fun to learn. But anyways, yeah, if any of you guys want to memorize it, it's really easy and it's really kind of fun, and yeah, I'll give you extra credit. It is pretty cool. But let's see here. So let's do.
I already started.
I know.
I must have headed you.
I haven't seen memory day.
What was that?
Oh, I'm just teasing Chloe.
We're competitors.
I'm telling her I'm gonna memorize it before her.
I will not make you sing it for me, but you
I'll
can
sing
like
it.
kind of record it and just send it to me. I won't post it. I won't have you sing it in front of the class.
I'm not gonna sing it. I'll sing it though.
You have to sing it.
So my daughter.
Duet.
My daughter does music, and that's how we did classical education our entire years whenever they were younger, right? We didn't have tutorials and co-ops where I lived in St. Louis. So like I classically educated them. So everything they learned to song, right? Everything they learned to song when they were little. And then it's kind of like the ABCs. You don't know what the ABCs are when you're 4, but you learn them. And then you start realizing how to use the ABCs as you get older. So, so my kids memorized by learning songs early on. And then later on, they're starting to, put things together. So my 18-year-old daughter's at Lipscomb, and she was taking Greek. And in the class, they talked about, I think it was like the Greek alphabet. Day 1 of class, they had to have the Greek alphabet memorized or whatever. And he is like, okay. He's like, Reese Milford. He goes, how about you stand up and tell us the Greek alphabet or something? And she kind of like was real sheepish, and she's like, well, she's like, I memorized it to song. So he's like, all right, go for it. So she had to sing the Greek alphabet to her class. And she's a singer, so she's got a beautiful voice anyways, and she's used to singing in front of people. But it was really funny that she's just like, Mom, I had to sing the Greek alphabet in front of my Greek class. So anyway, he actually made it really fun. He played like the bebop drums on his desk while she did it. And he made it really fun for her. So, but anyways, if you ever have to memorize something, singing it, finding a YouTube video that has it to song is a really, really good idea. Okay, so magnesium will look like this. So one of the things we've been studying the periodic table already really well, so you guys probably know what most of this is. What is that?
The atomic number.
The atomic number, yeah. And then what's the abbreviation for that again?
Z.
Z. And what does that mean? What is the atomic number?
It's the number of protons
Mhm.
and neutrons.
Yep, it's the number of protons, which by default then is the number of electrons. Yep. So the atomic number. So you might see in some of your questions on the quizzes or whatever, or your tests or your homework, like Z equals this. That just means like that's basically your element's address, right? If they say Z equals 20, you're like gonna go to 20, and that's calcium. So this right here is obviously the what? The name.
The element.
Of the element. This is the what?
Abbreviation.
A symbol or the abbreviation. Make sure, and I know I've said this before, but as we get going, people who tend to write lowercase, they kind of forget this, but you absolutely have to do, if there is uppercase, 2 letters, has to be uppercase, lowercase, okay? Absolutely, because otherwise someone's gonna write that, and I'm gonna be like, I don't know what that is, right? That looks like it's 4 elements, 1, 2, 3, 4. Or they're gonna because they like to write really little and cute, they write it like that. I'm like, I don't know what this is, okay? But if you write it how you're supposed to write it, we can all read it, right? This is the capital letter lowercase, this is capital letter and lowercase, and then now I know it's calcium and chlorine, okay? So really, really important. Let's see. Sometimes the symbol obviously does not line up with the name, right? I think tungsten, number 74, is actually W. Where does the W come from? I don't know what it's really called, like in Greek or Latin or whatever, but somehow W is the elemental name for tungsten, or the symbol for tungsten. Let's see, we've talked about this before. What is this one again?
Atomic mass.
Yep, the atomic mass. It's the average atomic mass. What are the 2 units of measurements that can be used? I think I went over this earlier.
Dalton and is it U?
Just a U. Yep. So you'll see the periodic table does not put a unit of measurement. I never know why, but I think they just assume that the less on those squares, the better, because it already gets kind of messy. But that's either in Dalton or U. Like it's like a standardized unit of measurement for atomic mass. And why is it average atomic mass again? You guys?
Because it's the average of all the masses of the isotopes that are naturally occurring.
Yes, yes. It's the average mass of all the naturally occurring isotopes. Very, very good. That's what we did with the M&Ms and like the mini M&Ms versus the peanut or the regular. Okay, and then what's this down here? I think we went through this in this class.
Electron configuration.
Yes, electron configuration, right? What does this first one mean? What does that one mean? Like that 2 versus the 8 versus the other 2. Any thoughts?
I don't remember this for some reason.
Is it? No.
I don't think I went through it in a lot of detail with you guys.
Is it like the number of electrons?
In what? Yes.
The
Oh, the sublevel.
The principal energy levels. Yep. Yep. So remember,
we got there.
yes. So here's again my shoddy
Oh wait. No, we did go through this.
Right, here's principal energy level 1. Here's principal energy level 2. This is really shoddy, guys.
Oh, I got it now.
Totally
I
not
got it
accurate,
now. It came
right?
back to me.
So all the principal energy levels, right? So there's hydrogen and helium in principal energy level 1, and that makes up the S sublevel, right? There's the S over here. And so, sorry, 2 can only fit in the first sublevel, or not sublevel, principal energy level, right? So there's 2 electrons in that very first principal energy level.
And it's a sublevel.
No, not sublevel. These have nothing to do with sublevel. These are just the principal energy levels, okay? So sublevels are like S, P, D, and F, right?
That's what I thought it was. 'Cause,
It's an
Yes, so this right here is saying first energy level, first principal energy level, there's 2 electrons. There's 8 in the second principal energy level. You're filling it up. There's 2 in the second or the third principal energy level. So that's telling me magnesium's like right there.
yeah.
Okay? So because there's only 2 in
Oh, I
that
see, I
third
see.
principal. So if
Yeah.
I said how many principal energy levels are there used in magnesium, you would say 1, 2, 3.
Yeah.
You can look there, or you know that magnesium is in the third principal energy level by looking at the periodic table, like right here. It's literally right there, right? So that is 1, 2, third principal energy level. Okay? And this right here corresponds with chapter 5, that equation, right, that you guys learned. So the first principal energy level, 2, if I put N as my principal energy level, 1 squared is 1 times 2 is 2. Only 2 electrons can fit in that first principal energy level, right? And if I made that a 2, 2 times 2 is 4, 4 times 2 is 8. Only 8 can fit in that second principal energy level. So they're basically saying that principal energy level 1 is full, 2 is full, and there's 2 in the third one. Okay, so what then, I think we went through this, is significant about the electrons found at the very end of this little ream of like electron configurations?
They're the valence electrons.
Yes,
then
these are the
average
valence
energy level.
electrons, yes.
I knew that.
These are the valence electrons because they're the ones found in the outermost principal energy level, which is your definition of a valence electron. Right? So, we went through this, right? I can't remember if I went through with everybody. So like group 1 has 1 valence electron, 2, 2. Skip all those. 13 has 3, 4, 5, 6, 7, 8. So another way you can find out is just to also look at this, right? So like chromium number 24 has 1 valence electron, right? You can see it right there. Okay. All right. One more little thing, and then, excuse me, and then I'll go through a few questions for you guys. Okay, so these right here, 1, 2, 3, they're principal energy levels, but what are they also called? You guys remember?
Oh.
Wyatt.
Oh. Periods?
Yes, periods. So they're called periods, okay? I remember this because when I'm writing a sentence, yada, 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 they go horizontal, and then there's a period, okay? So they are horizontal. Their periods are this way. And then, what are they called going up and down?
Groups or families?
Groups or families, Groups or families. Okay. Groups or families going up and down. And then this way, periods, or principal energy levels, whatever. There's a lot of different names for different things. Okay, so let's do a few more small things on the periodic table before we move on to like questions. Let's see here. Okay. So the periodic table is divided into a lot of groups. Okay, 6.3, you'll see they're going to go through characteristics of basically every single, every group. Okay, for the most part though, these that I'm going to focus on real quick. So over here, where does that start? It starts, again, this is a really bad drawing, but it starts here. Okay, there's this little line. What do they call that line? It's on all periodic tables. It's bold. It's kind of in bold print.
Wait, is that the stair thing?
Yeah, it's a stair step line.
Okay, that's not good. I just don't know if I like made up the step part.
Yeah.
I couldn't tell if I like just made up stair step
It
or
looks like stairs. So it's this bold line that you'll see on every periodic table, and the elements to the right and to the left, like along the stair step line. Do you guys remember what those are called? Anybody? They're called the metalloids or semiconductors. Metalloids are semiconductors. So if you look on page 122 and 123, it would include basically all of those along that stair step. Okay, it's to the ones to the right and to the left, right? Boron, aluminum, silicone, what's it say?
Both
Germanium,
sides.
yep, both sides.
Just the ones that
Arsenic,
are, like above and under.
yep. Antimony, tellurium, polonium. What do you pronounce that? Polonium? Polonium. I've heard polonium actually. So, what does that mean, metalloids? Like, have you ever heard of a word where you put oid at the end? Do you guys know what that kind of means when you put oid at the end of a word? I'm trying to think of another word, like a crystalloid, or a...
Is it like?
Like something, yeah. It's so it's like a metal in some ways. Yeah, it's kind of like something, or it's kind of like a wannabe. Okay, that's why they're called semiconductors and metalloids. Okay, this last end name, It means some of them can act like metals, some of them cannot act like metals, and it depends. Sometimes it acts like some metal, sometimes it doesn't act like a metal. They're semiconductors. Sometimes they conduct, sometimes they don't. It depends, okay? It depends a lot. So those right there have very questionable physical and chemical characteristics that scientists cannot determine for sure. Like, gosh, is this a metal or is it not a metal? So they call them metalloids or semiconductors. In general, what are these over here called? Not group 18, so not group 8, well, group 18, but what are these over here called? Are those your metals or your nonmetals?
Non-metals.
Nonmetals. Okay, so for the most part, over here you've got your nonmetals. And hydrogen typically gets put over there, even though hydrogen is over here. It gets put over there with your nonmetals too, okay? Hydrogen got put over here because in group 1, you've got hydrogen, lithium, beryllium, or hydrogen, lithium, sodium, potassium, like all of those. Hydrogen has the most characteristics of those group 1s, okay? That's why they put hydrogen over here, because it acts most like a group 1, okay? And because it has 1 valence electron, so does lithium, sodium, all of those in group 1, okay? And then all of these over here, everything else is considered then a metal, okay? So everything over here then is considered a metal. Basically, everything else. And then you guys will read about this again in more specific names of like what each one is and their characteristics. But down here, this F subblock, those are called lanthanoids and actinoids, okay? I don't know how to spell that. Lanthanoid.
I can get it for you. Hold on.
Thanks. A-N. O-I-D and actinoid. Okay, and you guys will read about their characteristics in 6.3, okay? But those are called the lanthanoids and actinoids. Okay, so the 4 big, whenever you take your periodic table and you categorize it according to their properties, okay, the 4 big ones are nonmetals, metalloids right along the stair step, everything else is metals, and then the lanthanoids and the actinoids, okay? Those are the big groups. Metalloids, nonmetals, metals, lanthanoids, actinoids, okay? Those are your big groups. That's actually 5, not 4. I think everyone just kind of puts together the lanthanoids and actinoids, even though they have separate characteristics. So one thing, and I hesitate to say this, but I think that I'm accurate in this. Most of the lanthanoid and actinoids are actually man-made. They're not naturally occurring, which I think is really interesting. So I find that interesting that there's actually elements out there that are man-made and they're not just naturally occurring. So I think like 99% sure I'm right on that most of those are. Okay, let's see. Okay, with that information, why don't you turn to your periodic table and I'm gonna go around and have each of you guys tell me some things, okay? Okay, so we will start over here, Wyatt. What is the abbreviation for bromine?
BR?
Yes. And what period is it in? No. So it's going to be, this is period 1, 2, 3, and then 4. So it's in 4. Yep. So I always think of it as, because I always think of it as like the groups going over. Yeah, so it's right there
I
too.
wrote that down. Actually, like sentences. Like
It is. So like I remember it by sentences, right? You write a sentence horizontally and there's a period at the end of it. So the horizontal ones are called periods. Okay. What group is bromine in? Groups are the one going up and down then. Those are the verticals, the vertical numbers. What group is bromine in?
That would be 3.
Let's see here. Bromine will be in 17. So these will be the group numbers. Yep.
Oh, okay.
Yep.
I'm getting the other things confused.
Yeah. And then, how many protons does bromine have?
35.
Yes. What is the atomic mass of bromine?
79.90.
Yep. And how many valence electrons does bromine have? Do you want to ask one of your peers for?
Wait, I might be totally wrong, but
Yeah.
is it 7? Look at the number at the
Yeah,
top.
you're right.
Oh,
Remember
the only thing I remembered.
So you can do it either based on, remember these have 1 valence electron, 2, skip all of these, go to 13. These all have 3, 4, 5, 6, 7, and 8.
So it'd be
Okay,
7.
so it's 7, yeah. Or do me a favor, flip to the back of your book. The very periodic table in the very, very back. So bromine is right here. It has 7, so you can also look there. Yep. Okay. Okay. And then also for bromine, is it a metal or a non-metal? Metalloid? Which one?
Be it metal?
It is a non-metal because it's over here. So these are all non-metals. Okay. Everything else is a metal. These are metalloids, and then these are the lanthanoids and actinoids. Okay. So I always think too, like if I try to think through like, you know, gosh, are those metals or non-metals? I look at the general, look at the, chlorine, chlorine's a gas, oxygen's a gas, nitrogen's a gas, carbon's not a metal. You know what I'm saying? So like, I kind of like generally look at them and I'm like, oh, okay, that's right. Those are the non-metals. Okay. Just to kind of get yourself, go with that. Okay. So we're going to go around and we're going to do 2 each. Okay. Chloe, look at polonium.
Hold on. That's one that I don't have.
Polonium.
Hold on. In a second.
What is it?
Polonium. Utilize your friends if you need to.
Oh, right here.
Oh, thank you.
All right, what is the abbreviation for polonium?
Yeah.
Mm-hmm. And what period is polonium in?
6.
Yes. Does everyone see 6? It's basically in the 6th row. So start with this one. This is 1. Yeah. And then metal, non-metal, metalloid.
It's a metalloid.
Mm-hmm. What about what group number is it?
Oh, sorry. Oh, I forgot they were also. Okay,
Mhm.
sorry. I forgot they were groups. I was thinking family 16.
Mm-hmm. 16. And how many valence electrons does it have?
6.
6. Yes. Because you can just know the 16 group and then take away the 10, right? Just 6. And then what is the atomic mass?
It is 209.
Yes.
Sorry, I'm dyslexic. I thought that was a G.
No, you're good. And
Is that
how many protons does it have?
it?
Yep, perfect. All right, so Ellie,
Oh, okay.
let's see.
You got it. Wait, are these ones the metal ones?
You're gonna do strontium.
Wait, what is it?
Strontium.
Wait, I need to find out. Hold on. Oh, wait, I actually just found it.
Okay. So what family is it in?
Wait, what do you mean? Like, what is the period?
No.
That's the other
Family
one.
is the other name for what?
Metal? Wait, no,
No.
I don't know.
It's the one.
Family is the other name for group. So group and family mean the same thing.
Okay, it's
Mhm.
2.
Yep, it's family 2.
Family
What period?
On 5.
Yep. How many protons?
2? No, that's valence. I have no. Wait. I don't know.
You know it.
You do
You know it.
It's the atomic number. How many?
87.60. No, wait.
the top one.
Sorry, my bad. 38.
38, yes. So remember that number is the number of protons. And then the atomic mass?
Is 87.62? No.
Yes.
Yes.
Yeah, uh-huh, yep. And
Oops.
how many valence electrons?
2.
Good job. Okay, let's see. And is it a metal, non-metal, or metalloid?
Is it wait. Hold on, it's a metal.
Yes, good job. All right, so Marina, I want you to do iron.
Ooh.
All right, so what family is
Hello?
iron in?
Wait, hold on.
Family,
Right by the center.
Hold on.
The top. It's. I can't say.
Oh, I see it.
Yeah, there you go.
What? You said what family?
what family?
It's 8.
8, which is also called, family is also called what?
Group
Group.
Group.
Uh-huh. What period is iron in?
4.
What's the abbreviation?
Fe.
How many electrons does it have
26.
when it's non-ion, right? And what metal, non-metal, metalloid?
8 is a metal.
And what's the atomic mass?
55.85.
Yes. Good. How many valence electrons does it have?
2.
Okay. It's 2, right, guys? I don't have that periodic table.
It has
I'm assuming.
right there.
Okay, cool. Perfect. All right, Wyatt. How about you do? How about you do phosphorus?
Oh goodness.
Which one?
Phosphorus. Let me know when you find it.
Oh, sorry, she says family. These ones are the families, like up top there.
It'll be
Okay,
horizontal.
okay.
Okay, I see, I see.
No, vertical. I always get those kind of stuff.
Oh, okay, I got it.
Vertical and then period
I
horizontal.
keep getting confused with like the valence electrons.
It's
like,
okay.
finding
It's over
that
here on
one
this side
these.
somewhere. Phosphorus. pH.
Oh, there it is.
Got it? Okay.
Oh, they don't. I'm using
All
your
right.
book.
Phosphorus is in what group number?
There's a lot with it.
50.
What period?
3.
What's the abbreviation?
P.
How many protons and electrons?
15.
Yes. What is the atomic mass?
30.97.
What's the atomic number?
15.
Yes. And how many valence electrons?
5.
Yes. Is it a metal, a non-metal, or a metalloid?
Non-metal.
Yes. Good job. Okay, perfect. Chloe, why don't you do gallium?
Got it.
All right. So what is the abbreviation?
Oh. Sorry, say it again.
Abbreviation for
Oh,
gallium?
GA.
What's the atomic number?
31.
The atomic mass?
69.72.
What's the group number or family number?
It is 13.
And the period?
4.
4. How many valence electrons?
3.
And what else can I ask? Is it a metal, non-metal, or a metalloid?
It is a metal.
Cool. Good job. I still need to bring gallium. Maybe I'll try to remember to bring it on Wednesday. It's really cool. Do you guys remember the characteristics of gallium?
Is that the one that like melts?
Yeah.
Yeah.
Yeah, room temperature, like it's totally
That's so
solid,
cool.
but you put it in your hand and you're a little bit warmer and it just kind of melts and it's this liquid metal. It's really cool.
It's like oobleck.
Yeah. All right, Ellie, you can do argon.
Wait.
Argon.
Where is it?
Let me know when you find it.
What is it? Argon.
Oh, it's on the.
Oh, I found it.
Okay. So argon, what's the atomic number?
18.
And what does that tell me? That has what?
18 protons and electrons.
What's the abbreviation?
AR.
How many valence electrons?
8.
What's the atomic mass?
39.95.
Good. And is it a metal, non-metal, or a metalloid?
Non-metal.
Good. And what period is it?
It is 3.
And what group?
Wait. Oh, 18.
Yeah, good job. All right, perfect. And Marina, you can do. I'm gonna have you do rubidium.
Hello. Wait, I can find it, guys. I can find it. I can find it.
Oh, I see. Wait,
No worries. I'm gonna stay quiet though.
You got it, guys. You said
Rubidium.
interesting. Oh, I found it.
Okay, so what period?
5.
What group?
1.
Atomic number?
37.
Abbreviation?
RB.
Okay, and metal, non-metal, metalloid.
It is a metal.
And atomic mass?
85.47.
Mm-hmm. And how many valence electrons?
1.
Yes, good job. All right, you guys got the hang of it?
Oh, yeah.
Yes, okay, cool. All right, let's move on. Let's see here. I'll send this to Kaylee too. Or I'll send it to everybody. Okay, let me see if there's anything else I want to go through there. Okay, 6-2. We're going to be spending all of next class period on 6-2. I've got 3 minutes left, so I'm just going to do something real quick, and we're going to look at atomic radius. What does radius mean? Like in math, what is the radius?
It's
Or geometry, I should say.
it's like half of the length, right?
Half of the diameter?
Yeah, yeah.
Yes, yeah. So it's from the center, it's from the center to the outermost point, right? So atomic radius is from the center of the nucleus to the outermost electrons, okay? The outermost electrons. So if you've got your nucleus here with your positive charges, and then you've got, you know, your 3 electrons, whatever. So your radius is going to be from here to here, right? Your atomic radius. So if you look at the trend, I'm going to be on page 127. If you look at the trend, guys, let's say this is your periodic table.
It gets like smaller.
It gets smaller going this way, okay? It gets bigger, that's why I put the plus here. It gets smaller going that way, okay? Why do you think that is? You're adding protons, you're adding electrons. Why are you getting smaller when you go to the right of the periodic table in general?
I know, I just don't know how to word it.
So let's look at period 4. So if you just count down 4 rows, right? Period 4, hydrogen, lithium, sodium. So that very first one, which is a pretty big circle, that's actually potassium, right? It's pretty big. And then as you keep going down the period, guys, it's getting smaller and smaller and smaller. That doesn't make sense. You're adding protons, you're adding electrons, okay? The reason why you're getting smaller and smaller, it says in there, is because you're not adding energy levels, right? Your energy level is staying the same. You're still in energy level 4, but you're adding protons, adding electrons, and so that attraction between the protons and the electrons is making it stronger and stronger and stronger and stronger and stronger, okay? So that's why it's getting smaller and smaller. You're not changing energy levels to where those electrons are going to be further away from the nucleus. You're just adding to this one energy level and it's making it tighter, basically, okay? So even though you're adding protons and electrons, it's to the same energy level. And so it's just getting that tighter and tighter and tighter pull, okay? So that's why it is getting smaller going from left to right. And then real quick, you're gonna get bigger going from top to bottom, okay? And if you can see the trend there, like if you look at group 1, hydrogen is super duper tiny right here. Then if you look down all the way at the bottom, we'll talk about the red dashes later, but all the way down, I don't know what that is, beryllium maybe? Like it's super, super big. Why do you think that is? What are you doing as you go down the different periods? You're adding a what? You're adding a whole new energy level each time, right? So you're adding a whole new energy level, right? Even though you're adding electrons and protons, those energy levels are getting further and further and further away. So those electrons are getting further and further and further away, okay? Because those electrons that you're adding are way out here. And then those electrons, that nucleus doesn't have quite the pull on those outer electrons, okay? So that's why it's getting bigger going down, and then it gets smaller going that way, okay? I've got this handy, which I'll make copies and hand it out for you guys. I'm gonna show it here on this, but this little handy thing that they give me here, I'm gonna make a copy and give it to you guys. I think I have laminating paper at home, if I can laminate it, but it's super handy because all of the trends that you read in 6.2, it tells you all of the trends. So they're all right there in this little piece of paper. But we'll discuss why the trends happen the way they are on Wednesday, okay? All right, thanks guys.